Good evening. Oh, okay. I hope everyone can hear me. All right, thank you very much. Welcome to October's NOSP event for 2023. We've got a really good evening lined up. You'll see on the slide at the moment all our sponsors. We can obviously do this without them. I'll go a little bit. We've got a kind of a mixed bag of presentations tonight, or mixed evening. I've been looking forward to this evening all year, to be honest, because I wanted to bring together some students and industry. And I think we have, just on this row alone, this one here, we've got some great people from the industry, and over there we've got students. So I think a nice mix of people. So I would encourage people to talk when we get to the break. I'll come on to a little bit about that later on anyway. So yeah, my name's Stuart. I'm kind of the chairman for NOSP. I've got five. We are a team of 5. We're going to go down to 4 soon, and then we'll go back up to 5, and hopefully we'll go to 6 in about 2 weeks' time. So we're only 3 here tonight, 4 by the end of the evening. That's part of the gig this evening, is we have to present to you guys, and we won't take up too much time. Hopefully we'll want to just crack on with the presentations, but we have to do it, and we haven't done it for a couple of years, but we have to present the numbers, the finances, what the plan is for NOSP, and hopefully we can get some feedback from you guys about whether that's actually worthwhile, or if there are any comments and any recommendations. So there's first 15 minutes will be an AGM, annual general meeting, and then we'll just crack on with the real reason for coming out tonight. So yeah, this is the real reason for coming out tonight. Some 4 fantastic presentations, in my opinion, and as I mentioned, the intention is to try to get a little bit of traction with how industry and academia work better together. We've got 2 graduates who've just come from Equinor and OneSubsea, and then we've got 2 students who are going to go out into the world. Well, not 2 students, we've got several students actually from Hogeschool and Professorlanda who are going to go out into the world and look for employment next year. So I think it'd be very interesting to get their take on it. And that last presentation will be concluded with a bit of a discussion about how we can bring this, or how we can work closer together. As a department manager myself, we struggle to get people involved in offshore. There's just the same old names going around all the time, Julian. So there's a lot of the same people just inhabiting it, and they're all very high quality, but we need new blood in, and we need new ideas. So I'm really looking forward to that. We'll just open the floor for about 10 minutes and discuss how we can do things a little bit differently. So a little bit about NOSP. Obviously, most of you hopefully know now what we're about and what we're trying to achieve. The statutes are on the website. We've got our annual dinner coming up, which is the conclusion to a pretty hectic year. I think I'd actually just want to go to sleep. I don't really want to go to Stavanger to drink myself stupid. I think it's going to be a great evening. Always very, very raucous. Last year's was really good fun. So I would recommend people, certainly within the industry, we can bring down, or the sponsors get 2 tickets for the dinner, and we can take some students as well. So if you are interested, and you've got a connection to a sponsored company, then it's possible we could get you down to that annual dinner as well. That's a great networking opportunity for students, so bear that in mind. But it's usually very good. I'm actually talking and I'm presenting something. We're going to have Restart, who are very well known within the industry, and they're going to give a market outlook. They do that every year, and that's last year's was very positive, and I suspect this year's will be very positive too. So and then we've just decided this year that we're going to branch out and do something a little bit differently, rather than have more industry or subject matter presentations. I'm going to talk about a motorcycle trip I did through from Anchorage, Alaska to the southern point of South America, and Odd, who's also in the NOSP team, is going to talk about him going across Greenland on skis. And we're looking for one more. So if anyone's kind of done anything exciting, like swum to the bottom of the ocean or gone to the moon, we would be quite keen to hear if someone wants to present that. So one more would be good. And we've now got the dates for next year. So 1st of February, we'll be back in this room, or maybe the next one over there. Bergen as well in May, and then again in October. So we've got all the dates, put them in your diary, because it's, and we've got to obviously start to try to get some sort of themes going for the evenings. Speaking opportunities, we always struggle. This one came together quite well, although I think it would, it's always a challenge trying to get people, whatever, whether they're industry or in the academia, to talk. So if you do have anything you would like to discuss, or shout and drop one of us a line in the NOSP board, and we'll put you on the agenda. So, a little bit about the annual general meeting. We have to do this every year. We haven't done this for 3 years, so that's my bad. We've been busy. That's my excuse. So this is just a little bit brief overview of what we're about, what kind of the stuff that we've been doing this year. This is actually an annual general meeting for this year, actually, and we're going to present the numbers for this year when we're almost into 2024. So it's all arse about face, but we have to do it. It's part of have to be transparent, as we're a volunteer charity. So yeah, it's good that we get into the gist of this, because I'm gonna have to do this again next year. And yeah, if you've got any pointers, let me know. So yeah, this year's been awesome. I think just the mere fact that we're up to about 40 people in this room is brilliant. We've this time last year, we were struggling, I would say. We would get 15 down in Stavanger and maybe only 20, 25 up here. So this is really good and an improvement. I think everybody in the industry is a little bit tired, me included, because everybody is working very hard at the moment. So a lot of the guys from the industry, from Bergen, aren't necessarily coming along to events like that, which is a shame, but I totally get it. So we really wanted to appeal, though, to a more student base, get you guys, and from Bergen, from Stavanger, from anywhere, get a little bit more focus onto the students and see how we can do that, because we need to think about, especially in survey and this country as well. In the UK, where I'm from, of course, it's we've got a little bit more focused on survey and offshore survey, but oddly in Norway, not so much. So there's something that we can do, and I think the only way we can do that is to talk to you, get you along to events like this, and see if we can improve things for us. Generally, have some people to hand over to when I finally will retire, amongst other people here who are going to retire in the not too distant future. So yeah, it's important that we focus, and that's really my focus within NOSP, is actually the students and getting people involved. Yes, I think the biggest event that we ever have all year is the RTS event. That was, again, that was a real corker of an event. I thought we had 6 or 7 presentations which were just outstanding, and that's been a real highlight for this year, and I don't doubt that this evening will be the same. Really exceptional presentations, different types of presentations, but all of a very high quality. So no pressure to those guys talking tonight at all. So yeah, like I say, increased student interest considerable. Just look around the room at the time and moment. We've got an increase of 6% in sponsors, so we're now up to 36. You'll see them in a minute as well. Yeah, we only recently got a company called Nortec involved, so that's very positive. Maybe if we can reach 40, that would be a nice goal for next year. But there is a limit of how many sponsors we can get. There are only so many companies that are actually involved in subsea. One subsea is not a sponsor, so maybe you can have a word with upper management. Yeah, we've reduced the number of events. This is actually quite hard work putting all this stuff together, so I do appreciate everyone coming along, because we were doing it 6 a year, so now we've reduced it to 5, and the goal really is quality, not quantity. And I think we've shifted things by having themed evenings, whereas we would normally just have 4 presenters. I think that's worked better as well, and tonight is a good example, an opportunity for students and graduates to talk. January, I haven't got a clue what we're going to do, so they're going to come up with something quite quickly. Yeah, assistance, as I mentioned, with presentations and evening things, please, if you've got any ideas, come up with them. Just call. We're going to have a break later, halfway through the evening, so come up to me if you've got any ideas. We've now got 500 people on the mailing list. I actually put people on the mailing list even though they don't even realize they've asked to be on the mailing list, and I hope that's okay. But that's really important. Getting more coverage for NOSP is really important, and the only way to do that is surreptitiously. So Yeah, one thing we're going to do, and we're going to change over the next couple of months with the inclusion of a new person into the evening, which is ultimately what we're going to do towards the end, is increase some social media advertising and appealing to a younger audience. We struggle with that basically because we're all very busy, but we obviously, I don't have a clue either, and I don't want to get too involved in social media, but it's an important part of it. And if we can get increase the social media side of the NOSP, I feel that we'll can get more people involved in create more interest. So as I say, just to finish there, any ideas and comments are always welcome. So that's kind of a summary, I think, of what we've done in 2023. Yeah, for 2024. Right, so I'm just going to say something about the members fee. Like I say, this is kind of what I've got to do, so apologies for just kind of saying it. But the members, you guys, this is all free. The sponsors, of which we are several here tonight, I'm one of them, DOF Subsea, Fugro, etc., BSR, they all pay 10,000 kroners. That's the reason we can rent this, because this is not cheap. The food's high quality, of course, from Kolonialen. So yeah, we're going to keep that. We've returned from pre-COVID times where it was 5,000 and all online, and now we're 10,000 kroners and back in-person events. So those are the guys, 36 of them this year, which is up from about 28, 29 last year. So yeah, and what we are going to do, especially for you guys, is we're going to improve the interface that we've got, the website. It's just a little bit old hack at the moment, and we're going to ensure that you guys have got somewhere to go. Students can go to see companies, what they do, what their basic kind of premise is, and also we're going to try to get jobs on there as well at some point as well. So I think that could be a good opportunity. So if you've got any ideas of what you would like to see on a NOSP website, then please let us know, because we're going to, in the new year, spend some time and money on improving that interface. So not just for these guys, but for you too. I think it works both ways. Right. So, oops, I just, so yeah, there's an action plan and budget for 23. I'm going to hand over to Ricardo in a moment, but the action plan for 2023 is really, as I mentioned, increase the profile of offshore survey to the next generation of surveyors. So it's, you know, I think it's a passion that we've got. Julian, I probably would say that he's got, under his own breath, would say, a lot of people in survey would say, oh yeah, we don't want to really work in survey, but actually I think we'd actually quite like it. And that's the reason why we've been in the industry for about 25 years. So it's really important to get the next generation, you guys, students, involved, and we'd like to help you out and do that. So on that front, that's our action plan. The budget, I'm now going to transfer over to Ricardo, who's my wingman in NOSP. So thank you for being my wingman. I will hand you the floor. So yeah, talk about the numbers.
Thank you very much, Stuart. Is it up and running? Good, excellent. Good evening, everyone. I'm Ricardo. So I'm, like Stuart says, I'm the co-chair, treasury, IT, and everything else. And I also do part of treasury and finance. So we haven't been doing this AGM through some years, and now I'm going to present some numbers for this year and maybe have a quick look into the years as past. So I'm in the board since 2021, 2 years, and I work in Perseus, that nobody knows. It's my own company. So good. I think going back a little bit to 2021, when we had COVID, so we had the sponsorship for NOSP of 5,000 due to the Corona online events. We didn't need to have this type of facilities to have the events, but there is a result for that. So the year result for 2021 was minus 61,000. 2022, we did not change. I'm not sure if it was a good thing or not, but any guess? Minus 62. The prices didn't go down. So let me just to give you a heads up. We had 34 sponsors in 2022, so 5,000 times 34 is not that number, but is very similar to that number. So this is, there are always some invoices through the year, passes to next year, and same the other way around. We got as a in Tecker 155,000 in our accounting. That looks a lot, but just to give you a general idea of how much do we actually spend at NOSP. So we have the accounting services, which is either. So I'm the treasury, but luckily someone does the actually accounting, so no worries. Someone takes care of numbers properly. We pay the yearly fee for them, and whenever they need to do extra time for invoicing this and someone didn't pay, send reminders and so on. We also need to pay extra for that, and we need to pay also for their software. We have general expenses also towards software and IT. So we have StreamYard, we have the Google account, we have also the domain through Pro ISP, like every company has, and we have some small IT support when necessary. We are not IT experts, so sometimes John makes a really good work, but sometimes we need someone to step in. And of course, we have the room facilities like this one for the events, drinks, finger food, like you can see on the back. In some places, we also need to pay extra for TV, speakers, and so forth. Not in this place, but the annual dinner and some other places in Stavanger where we had to pay extra. Some mobilization costs are also covered. When we have, for example, special guests, then we also have Kahoot, software for special occasions. We had Kahoot last year. This year, I'm not so sure if you're going to have it. But the main thing is the dinners for the sponsors. So that is that's the big slice that we have to pay. So all in all, we have for 2022, again, we had for the accounting services around almost 50,000. We had basically almost nothing for IT support. John has been doing a really great job there, so we saved some money on there. For the hardware, we actually bought this laptop because we were running in my own laptop, and after some presentations of at RTS, that the presentation stopped and happened several times, so we decided to have something proper, and it's not cheap, so we spent around 22,000 there. And then there is some minor costs here that the accountant says is not documented, and the other one is invoices that hasn't been paid. So not documented, it means not that it's too small, so it's not registered as an invoice. That's what it means. Then we have small fees for the banks administration, and then we have for 2022 we have 152,000. So as total cost, we have 237,000 for, and then we have some unfinancied, and I hope no one is going to ask me what is that, because I have no idea. But we came then from minus 64, was it, to minus 82,000. So this is the road that we are going to have, and I didn't have time to put a graph, but it's quite clear that we cannot be sustained on 50,000 a year, considering what we actually do at the moment. So for that reason, we came back to the 10,000 and see if this is sufficient or not. What can we do? Do we need more sponsors, or do we need to actually increase the fee? And what's the year result? We do not know yet, because the accounting closes in December. We're going to have some months, and so we'll know somewhere middle of next year. But for now, we have confirmed 28 sponsors, and plus 6 is sponsors that says they're going to sponsor, but it's not there in the bank yet. So we have received so far 280,000 and as an income. A little bit of the expenses that we have in terms of reclame-kostnad. So we try to grow, like Stuart says, our vision in LinkedIn and social media to promote the events, to share this event, and that people know what we do. Also to see it in YouTube. And we are not experts on that. So like IT, sometimes we need some extra help to come and to guide us on how we should do this in a professional way. We bought 2 roll-ups. One of them is in the door. The other one is in Stavanger. They look really good. And we have some gifts that run out empty. So we need estimation there. The asterisk is estimation. Roughly 10,000 for more gifts for the presenters, which, by the way, I need to talk with you guys a bit later about that. Software and IT support this year, same as before, StreamYard, Google, domain, and IT support is altogether under 2,000. So it's small costs that we are looking at. Looking at the big costs again, events. Then we have for this year, we had in February in this very place, the first event costs around 21,000. Then we had the second event in Stavanger with Innova. So it was at their facilities. It was actually nice because we just paid for the food. And we saved quite some cash there, 9,000. And the third event was again in May here in Bergen. I think most of you were still here. We got a huge bill of 41,000, but that we got a credit note back, and that was actually shared with the NPS. So this one, what is normally here is around 30, 35 with the food and everything together. Then we have Subsea Innovation Day. So that's also, again, good for RTS that has facilities, and we have small costs for that. And the annual dinner that comes now in Stavanger. So are you looking at the number? Yeah, that's our budget. Yes, so for the expenses for this year, the accounting is going a little bit more than 2022, 52,000. IT support, we expect to have some small IT support because we might need that for our website. We need some appointer, so more or less 600,000. And then we will have there in the other costs, I think is just the same as 2022, this 5,000. I need to check this with the accountant, how to remove those small things. Bank fees, a little bit more than in 2022. And that's it. I don't remember the reclame-kostnad anymore. Oh, I already talked about that. That was the LinkedIn and the roll-ups. Yes. And the events altogether was 198,000. If I can go back, 198,000. Yes. So as sum of our expenses is 285. If we subtract that from the 280, we have only 5,000 less. So that's the estimation for this year. Instead of having the minus 82,000 that we had last year, we will have, I don't think we're going to have -5 because we have 6 more sponsors that says they want to be a sponsor. We just didn't get the paperwork done ready. So I actually think that we will be positive in the end of the day with around 20 to 30,000 this year. Yeah, and I think that's it. Any questions in terms of accounting? All right. Thank you.
Thank you. I'm sure you're all fascinated by that. That's actually kind of it's the formal side of it, but it's very necessary. We need to be transparent. Like I say, we can't buy ourselves cars and drive around in posh Lamborghinis. We need to be transparent, and it's very important that we have control of the numbers and we spend the sponsorship money very, very wisely. So yeah, thank you very much, Ricardo. Appreciate that. I don't get involved in it. I'm thankful for you. So right, so I think I'm going to wrap this up quickly because we've gone on far too long already and we haven't even got to the reason why we're here tonight. So there's one thing that we do need to do, and that's, you see my name at the top, Ricardo's there second, and John, who sat on the middle row there, this is probably John's last event for us. He's been with us since 2013, so right from the very start. It only dawned on me earlier that NOSP is 10 years old and we haven't had a birthday party, so maybe we can have that later. Derek is based in Stavanger together with Odd, but yeah, so we're going to be down to 4 once John leaves, but we wanted to put, we've had a 5th person, and the point of this event is that you then put that name forward, and then if anybody's got any objections, you tell me. So basically, Elizabeth, who's sat here, would you just like to stand up, Elizabeth, with your new haircut? Lovely, by the way. So if anybody's got any objections, we're going to vote Elizabeth onto the board, please. Anybody? All right. So John objects, but so basically that means Elizabeth becomes welcome back to NOSP, which is you left us in 2019, I think, to have yet another child. So, but what we're going to do is we would like 6 people involved. So Elizabeth's role is going to be young person initiative, and we haven't really landed on do you like it? Oh yeah, I came up with it earlier. So the intention though is to have 6 people. So what I would like is to hear if anyone would like to help us out here. We don't have a vast budget, as you've seen. We can't offer a company car or pay the telephone bill, but there is an opportunity here. If anybody wants to get involved with NOS, we'd like to get a 6th member on board. We're not quite sure what they'll do, probably do all the stuff that we don't want to do, but it doesn't matter. It's very important. It's a very important role. So if anybody here is interested, Lisa? No? If anybody's interested, then please just come and have a chat with us. We'll try to, if I do any names, then we'll try to make a decision by the annual by the time the annual dinner comes round. So that is it. So Elizabeth, welcome to the club again, and if there's anyone else wants to show interest, do so please. So that is it from me. That's the end of the annual general meeting, my first one with NOSP. I thought it went swimmingly, and you'll get exactly the same one this time next year. So that's probably not the right thing to say, is it, to get people along to an event? But anyway, it's a necessary part of being NOSP. So on that note, I'm going to pass over I think we'll have to change the presentations and bring up Per Helge from Equinor. As I mentioned at the start, this was quite good. This fell together really well. We had 2 guys who are recent graduates, although you look like quite a mature student. Are you a mature-ish student?
A mature student. I'm 27.
You are a little bit mature, as is Guy. But that's okay. It's really important. We've got some graduates who recently graduated, and then we've got some masters and other students to present the evening. So I'm going to stop waffling, going to go and get myself a glass of water, and I'll hand you over to Per.
Thank you. Yeah, do you hear me? Yeah. So I'm going to present my master thesis, which I did last year in about the GNSS and multipath. So I think I will have a short introduction of myself first. My name is Per Helge Årnes. I come from Surnadal, Nordmøre, in Møre og Romsdal. I'm 27 years old, and I studied geomatics at the Norwegian University of Life Science from 2017 to 2022, with a specialization in geodesy. I wrote a master thesis about GNSS on behalf of the Norwegian Space Agency with Ola Østedal and Christian Rost from the Norwegian Space Agency as supervisors. And I joined Equinor as a geodesist in August last year. The content for this presentation, I will first take you through the background of the problem statement and a little bit about the method and the result from the different computations. And I will end the presentation talking about the challenges and weaknesses of the study. So, what is multipath? Multipath is a very important source of error when it comes to satellite-based navigation. And it means that the signals are not always taking the shortest path from the satellite down to the receiver. But the signal gets reflected from buildings, the road, vegetation, the ground, whatever. And the indirect signal are interfering with the direct signal and causing errors in the observed pseudo-ranges. So you get an error in both the code and the phase observations. Multipath affect both code and phase, but the effect on the phase observation are pretty small. A rule of thumb is that the effect on phase is around a quarter of a wavelength, so around 5 centimeters. The effect is strongly dependent of local conditions. In an open area, the effect of multipath is small, but in urban environment, the effect is big. And the systems are affected differently of multipath. And to do a performance evaluation of a system and different signals, you need a GNSS data set from an environment that have changed a lot or undergone substantial changes. So the Norwegian Space Agency picked a permanent GNSS station at the roof of the Opera House. This station is operated by Kartverket and is part of the network RTK called CEPOS. And in this area, there has been substantial changes. We have Barcode, we have Deichman, we have Munch Museum, different building that can increase the effect of multipath in this area. This is a well-suited area for a time series analysis of the multipath effect. Here I added some pictures showing when the biggest changes happened. And if you take a look at 2015, we see that there's no building close to the Opera. In 2016, there's obviously some construction activity started. And in 2017, a lot of raw constructions have came up. And in 2018, most of the construction activity is finished. There is still some ongoing work on Munch's Brygge after 2018. So the problem statement. The main goal with the thesis was to perform a time series analysis of different GNSS observations. And the problem statement can be summarized as how has the construction activity around the CEPOS station affected the quality of the observations, and thus inclusion of Galileo signals like EFM Altbach make the position determination more accurate. And to answer these two questions, I did an analysis in both the observation domain, which is raw code and phase observation, and in the coordinate domain. And in the coordinate domain, what I mean with that is then you work in a geodetic reference frame. And I want to mention that this problem is not only relevant for the Opera House. This is relevant for all GNSS stations. So the method, the calculation can be divided into two main categories. Analysis in the observation domain, where the effect gets estimated by doing linear combination of raw code and phase measurements of observations. And analysis in the coordinate domain consists of a relative GNSS solution, differential GNSS, and a precise point positioning. In the observation domain, a MATLAB software called GNSS Receiver Quality Check 2020 was used. And for the coordinate domain, RTKlib is an open source GNSS software. So that was used in the coordinate domain. And since Bjørvika is known for subsidence, setningsproblematikk, so the result had to be cross-validated using an independent source, like INSAR, for instance. Data, 12 years of RINEX data from OPEC, which is the name of the station at the Opera House. It's worth noticing that the receiver was changed in 2015 to also support Galileo and Beidou, not only GPS and GLONASS. But the logging of RINEX 3 format was not in place until 15th May 2015. In other words, from 2010 to 2015, only GPS and GLONASS. This makes the total approximately 2 terabytes of uncompressed RINEX data. So there's a considerable amount of data. So a little bit more about the observation domain. Here we estimate the effect of multipass using raw code and phase observation under the assumption that the phase has no multipath. So we're assuming that the effect on the phase observation are 0. And since we are including phase observation, this means that the phase ambiguity, so I think several of you know that the integer number of wavelengths between the satellites and the receiver are then baked into these estimates. The way this was handled is that for each continuous segment or arc, the average was subtracted. Then this will be eliminated. But that makes it very important to handle cycle slips in the observation. And the cycle slips was detected using ionospheric residuals and a code phase combination. The ionospheric residuals is the time derivative of the ionospheric delay. So if this is above a predefined threshold value, a cycle slip is detected. Differential GNSS or relative GNSS, a base station at Ås was used to compute the vector or baseline, approximately 27 kilometers between them. And the calculation were done for each individual system and a multi-GNSS solution where all the system was included. Ionospheric free linear combination was used to eliminate the effect from the ionosphere, and the tropospheric delay was estimated in zenith. I used precise ephemerids or satellite coordinates from the analysis center called CODE. And since the Opera House is close to the Oslo Fjord, I corrected for ocean tide loading, tidvannets last, with these two models. I ran a pure float solution. I didn't try to estimate or fix the number of wavelength because RTKlib had some challenges to locking or making the ambiguity resolution if you used a ionospheric free linear combination. More details on that can be found in the thesis if it is of interest. The base station was set up in 2014, so the data for the relative GNSS is only from 2014 to 2022. Precise point positioning used also ionospheric free linear combination, but here I also added the horizontal gradients into estimated the horizontal gradients in the equation system as well as an unknown parameter. this is decreasing the geometry, but you are modeling the tropospheric delay better by adding this as an unknown parameter. GLONASS was very problematic in the first 5 years. Had to tune up the a priori standard deviation of the phase measurements so that not too many observation was filtered out as an outlier in RTKlib. I will come back to this. 30-second interval, and same as for the relative GNSS solution, calculation was done for each individual system. Precise satellite coordinates and clock correction was downloaded from code and corrected for earth tide and ocean tide loading here as well. But since PPP is using undifferenced observation, you also have to correct for phase center variation and phase center offset, phase windup, and differential code biases. I will come back to this last source of error because that's an important source of error in this study. So the result from the observation domain shows an increase of multipath for GLONASS and GPS for the C1C signal. And what's interesting is if we look at the x-axis here, we can see that this increase starts in 2015. And what happened in 2015? The building close to the Opera House came up. So we can link this increase in time to where the construction activity was at its highest. It's easier to see it in these plots, but it's actually showing much of the same. But for C1C, GPS and GLONASS, we can see there's something happening in 2015. There's also something happening with C2X, but the data before 2015 is too bad, so it's impossible to draw any conclusion for this signal. Here is the multipath effect plotted as function of time for the entire time series. We can see C1C for GPS and GLONASS. For GPS, it jumps when the receiver is replaced, and then it increases. And it's the same for GLONASS. But for the other signals, no increase. This plot is lying a bit. It seems like it's increasing, but it's just that more and more satellites are transmitting this signal, making each line in the plot closer, tighter and tighter. So it appears that there's been an increase, but that's not the fact. Here I created a GIF showing the increase as a function of the satellite elevation angle and azimuth. So we see that the dots becoming more and more yellow throughout the time series, indicating that the multipath effect is increasing. Another interesting thing is if you look 150 degrees north, there's something happening in 2016. It seems like we are losing data for the lower elevation angles. And if we look at the map, we can see that what is in this direction relative to the receiver, it's the Munch Museum. So it seems like the Munch Museum is in fact blocking parts of the satellite orbit for the lower elevation angles. You can see it in this plot. And in 2016, the raw construction of the Munch Museum came up. So for the relative GNSS solution, now we are in the coordinate domain. Now we are working in a geodetic reference frame. And we get precision and accuracy as expected. And what's interesting if you look at the blue bar here, the east component, we can see an increase around 2016-17. It's easier to see in the next plot. But this is for both GPS, GLONASS, and the multi-GNSS solution. We can see an increase in the eastern component. We see that the accuracy of Galileo is increasing very fast. It's bad in the beginning, and then it drops down. That is as expected, because Galileo was not fully operational in 2015. There was only 4 to 5 operational satellites visible from the Opera. So that's not a redundant equation system. So just a few extra satellites are bringing the root mean square value down. Here we can see the annual root mean square values and first order trend line. You can see this orange line is going upwards. There's a trend. And this trend have to be seen in connection with the estimated value r squared. If you take the square root of this, you get the correlation coefficient. So a high value here says that the data points are well described by a linear model. So we see for GLONASS it's 0.97, and for GPS it's 0.81. So it's pretty high. For the PPP, it's too varying and too poor accuracy to say anything about changes in accuracy. And we see that GLONASS has big problems the first 5 years. And then it drops down in the beginning of 2015. I will come back to that. We also see the same for Galileo in the PPP solution. The accuracy is getting better and better. And another interesting thing is that we get sub-centimeter level in accuracy for the multi-GNSS solution after 2017. So we are on a millimeter level accuracy. So that's good for a PPP solution. For the cross-validation, I used Inside Norge, a service from NGU, Norges geologiske undersøkelse. And I used 2 datasets, RADARSAT 2 and 1. And both these estimates are velocities, and they are within the measurement uncertainty. So I can't say that there's been a significant movement of the Opera House based on this. And in addition, we see there's a jump here in 2017-18. And NGU is warning about such jumps. So, and I also found out that the Opera House is constructed using 700 socket piles, pärlor till fjäll. So it's a pretty robust thing. I don't think it had moved at all. But around the Opera House, there's no doubt. There's a lot of nedsynking. We can see this, and the velocity is almost a centimeter, minus 9.35 millimeter per year. So this is a really big movement. So a little bit about weaknesses and challenges. The satellite constellation for Galileo was not fully developed at the time when the construction activities was at its highest. So we have too low number of operational satellites, making the accuracy too low. We can see here the connection between the deviation and the number of satellites. Just a few extra satellites bring the root mean square value down. And for Beidou, the Beidou performs bad the whole time series, and we see the reason here. It's only between 4 and 6 satellites. That's mainly because of the precise ephemerids or satellite coordinates from code does not include Beidou 3. So it's only included Beidou 1 and 2, which is primarily our regional system suited for Asia. So, but Beidou 3 is a global navigation satellite system. But that's not a part of this analysis. And here we can see the PPP solution for GLONASS, very high deviation the first 5 years, and then it drops down when going into 2015. We don't see this in the relative GNSS solution, suggesting that this has to be clock related. This is due to an error that gets eliminated when you are subtracting or differentiating the observations. So the only thing I did different in 2015 is that I changed the precise satellite clock corrections. So that's the only difference. So this must be, in a way, clock related. Summary and conclusion. The observation domain show increase of multipath for the C1C signal for GPS and GLONASS, and we can link this to the time when the construction activity was at its highest. And we see this both for the weighted root mean square values. They are weighted by the satellite elevation angles. And for the relative GNSS solution, we see an increase in the eastern component. So here you see the three lines, both the east component from the GPS, GLONASS, and multi-GNSS solution. And the PPP solution was, it was not possible to draw any conclusion based on that. It was too varying and too low precision and accuracy to draw any conclusions. And the Opera has not moved. I couldn't conclude with that. So I think that's what I plan to present. I also added some links if you're interested. The thesis includes more details about the different challenges. And I also added a link to a Python software that I developed after the thesis, so which is you can install with running pip install, so you can test if you want to. This runs this estimation in the observation domain. So that's it.
Thank you, Per Helge. I always, of course, have a number of questions, but does anybody else here, or shall I get the ball rolling? Because is the takeaway from this that the Opera House has not moved? Or
Yeah, that's the main takeaway.
That's the main thing. Okay. Can I ask how you obviously work with Equinor now? Were Equinor involved in this from the start? Did they sponsor you? I mean, I just presume I'm trying to link this to some of the students in here and maybe doing something similar over the next couple of years. Were they involved, Equinor, or was this purely off your own back?
No, Equinor was not involved at all. Okay. It was the Norwegian Space Agency that had this master thesis. So, yeah. Oh. So.
But they didn't offer you a job then?
No. I joined Equinor.
Yeah, you joined Equinor. Okay. Very good. I imagine for quite a few people in the room from one university that will be quite highbrow, but from the other college, I think they'll probably understand it more. And certainly from offshore work, you won't ever go into that deep kind of detail, but it's certainly something that you need to be aware of in the survey world, onshore and offshore. So are there any other questions at all for Per Helge, or should we say talk and...
Just a short one. Because you mentioned all the noise regarding the heights of the buildings in the Opera House. Is that common in the RTK Norwegian network to have the stationary stations that can be surrounded by buildings?
And most of them are not surrounded in like this, but they are placed in an open area. Like the one in Ås is a wide open area with low multipath. So, but Kartverket was aware, of course, of this, but it was good candidate for such analysis, just to see how building can affect the accuracy.
Okay, thank you very much, Per-Helge. That was very interesting.
Yeah.
Thank you. Okay, I'm going to welcome Geir to the floor. So Geir is going to talk to another demanding and technically heavy presentation, which I'm thoroughly looking forward to. Can I ask a quick, maybe I can ask you a quick question before we get started. You were working, you were a pilot before, and now you ended up working in the offshore branch. How did that happen? How did that occur?
Well, you want the honest answer or?
Money.
Yeah. No, so the reason, I mean, working in aviation is in many ways very different from working in a subsea environment, obviously. But at the same time, when you're flying aircrafts, you're very close to the technology, and that sparked a bigger interest for technology that made me start in Høgskolen, and I finished my engineering degree after that. And somewhere along the line there, I decided, this is what I really want to do.
But and maybe I should just wait for the end of this presentation. But you ended up with a sponsorship from OneSubsea, and but you'd obviously established a contact with them before you started this, and before, so you almost had built up a path into the OneSubsea based on what you were studying. Or were you, whilst you were studying, were you put in touch with OneSubsea or?
Well, it was a bit of both. It was kind of a coincidence. I got a part-time job at OneSubsea about 1 year ago, and shortly after we were to pick what bachelor thesis to write, and OneSubsea had a specific topic that we could choose, and we picked that one. I wrote the thesis together with two fellow students, and so it's kind of coincidence. Well, a lot of coincidences, but yeah.
I think life is full of a lot of coincidences.
Yeah, it is.
One of them is the fact that there are many people in this room who, 2 or 3 anyway, who worked on the same oil field that you're going to talk about, and they're sat in that row there, and where we used to work together. And Ormen Lange is probably an unknown field for a lot of people, but for the guys in the UK who get most of their cups of tea cooked by the gas that comes out of Ormen Lange, there's an awful lack of appreciation for what we've done for them. But I think it's quite nice that there's a connection between 2005 when we were working on Ormen Lange. I look at you guys, Per Norvald. We all kind of started our careers, I think, probably in that field. So it's quite nice to see that you're going to talk about it in your presentation. So I'll leave the floor to you.
Thank you very much for the introduction, Stuart, and thank you very much for the invitation for me to come and speak here. I'm Geir Grønlien, like Stuart said, and I now work for OneSubsea. Finished my degree as an electrical engineer at Høgskolen på Vestlandet this spring, and like Stuart also mentioned, I had a completely different job before getting into electrical engineering. I was a pilot on the jumbo jet, flying around the world. But at some point there, that sparked an interest in technology, and I ended up doing an electrical engineering degree as well. So you mentioned that I'm going to go deep into technical details of electrical engineering. I am not. I know that we all have different backgrounds here. So what I'm going to talk about today is, first of all, this new company called OneSubsea, and I'm going to talk about one of our flagship projects, Ormen Lange Phase 3, and then I'm going to more or less briefly go into the bachelor thesis we did at Høgskolen as well. So OneSubsea, I say it's a new company. A lot of you, at least the guys here with experience, might know this company here. But a lot has changed in the recent few days and recent few weeks. A year ago, SLB, formerly known as Schlumberger, together with Aker Solutions and Subsea 7, announced that they were creating a joint venture with the subsea business of SLB and Aker Solutions. And this joint venture is called OneSubsea, and it has 11,000 employees around the world, The headquarters are in Oslo and Houston, but we have, like I mentioned, offices all around the world serving all basins. We have 3 locations here in Bergen, and we have the location where I work at Sandsli, and that office there has heritage from Framo Engineering, a pioneering company that developed subsea compression systems. They've been doing that since the 80s. They also built the testing facilities at Horsøy that I hope especially the students here get to visit, because it's really fascinating place. That's where we both test offshore system before it's being sent offshore. But there's also a lot of development going on there. Very, very exciting. Ågotnes has its heritage from Aker Solutions, and that's also a place where they do testing of equipment. So the driving force behind this joint venture is that these 3 companies, SLB, Aker Solutions, and Subsea 7, see a huge potential in the subsea future. We know that the oil and gas industry will be with us for the next few decades to come, but subsea solutions and subsea products will be a key important element in decarbonizing or reducing the carbon footprint of that industry. And the project I'm going to talk about afterwards is a good example of that. Additionally, a lot of the new renewable sources of energy for new sustainable energy sources will use a lot of subsea infrastructure and subsea elements as well. Additionally, we see now that carbon capture, subsea carbon capture and storage is going to be big, and OneSubsea is involved in all of this. So joining the forces with these big companies like SLB, Aker Solutions, and Subsea 7, joining the forces from these companies makes this company hopefully one of the leading new companies going into the new subsea era. So now I'm going to talk about a project that I'm working on in OneSubsea, and I just joined the project now in the, let's say, the later phase. But Ormen Lange was discovered in the late 90s, and after years of engineering and surveying, they started producing gas in 2007. What's a bit unique about this gas field, it is that there are no platforms. Everything is subsea, and it's tied to Nyhamna, that is just outside of Molde, with 120 kilometers long pipe, gas pipe, and together with power cables and control cables. At Nyhamna, the gas is processed and then sent to Easington in the United Kingdom, and it actually delivers 1/5 of all gas that United Kingdom consumes. So it's very true what Stuart said, that, I hope your parents are sending you a thank you note every time they have a cup of tea, because it's obviously of big importance. Keeping that year, 2007, in mind, it's a bit interesting to see as well in this graph of the United Kingdom's CO2 emissions, where you see a quite steep drop just around 2007. Obviously, that's not just all Ormen Lange, but replacing coal with gas has been a very important factor in United Kingdom reducing their CO2 emissions. Ormen Lange today has produced more than half of the reserves available. And as you produce gas, the natural or the pressure in the reservoir reduces. And as the pressure reduces, the production also reduces. So we can see here from the peak about 10 years ago, the production has gradually decreased. But in 2015, they installed compressors at Nyhamna, so on land at Nyhamna. And these compressors increased the production quite significantly. However, there is a better solution. And given the company I'm coming from, it's quite obvious that the solution is subsea. So Ormen Lange phase 3, we're going to place compressors at the seabed. And this increases the recovery factor from 74 to 85%. That means that originally you could only recover 74% of all the gas in the reservoir. But with subsea compression, that will be increased to 85%. And this is, of course, a huge increase and very important. Also, being able to use more of a reservoir is very good for the CO2 footprint. Subsea compression, so putting compressors on the seabed, is not really a new technology. It's been around for a couple of decades, and Framo Engineering was one of the pioneers in doing this. However, one of the big challenges in subsea compression is delivering power to the motors that are on the seabed. Usually, there's a platform close by where you have a motor controller, and that motor controller delivers electrical power at the right voltage and the right frequency to the motors that are placed on the seabed. However, at Ormen Lange, there is no such platform. And it's quite interesting to read news articles 10, 15 years back where they were looking into how they were going to solve this. One of the plans was actually to create a big platform where they had these motor controllers being powered from land, but motor controllers have to be close to the motor. And they would have platforms just supporting this equipment. The alternative plan was to put these compressors together with the motor on the seabed. That's a very ambitious project. It's possible, but the problem with these motor controllers is that they have a lot of fine electronics in them. And when you're placing them on the seabed, if something goes wrong, it's very expensive to recover them again. OneSubsea, some very bright minds at OneSubsea, and I'm really happy to work with these people today, because they came up, or they said that they could actually put the motor controller at Nyhamna, 120 kilometers away, and control these motors on the seabed from Nyhamna. And some companies, not mentioning any names, they say, we don't see that happening. That's not possible. They did their own analysis. This is not going to work. So OneSubsea had to build a simulator at Horsøy, where they built a 120-kilometer long cable, and they proved that they could control 4 motors with just one motor controller 120 kilometers away. This was a huge milestone, and one of the reasons why OneSubsea got involved in this project. Another problem with the subsea compression is that the gas coming up from the reservoir is not just pure dry gas. It's a mix of liquid and gas and even sand. So on the original project, they would have to have these separators that would separate the liquid from the gas before it's being put in the compressor and sent to Nyhamna. OneSubsea had a solution for that as well. We have a wet gas compressor, and this compressor is driven by 2 electrical motors. One motor is put on top of the compressor, and the other one is put on the bottom, and they're rotating in opposite directions. By rotating in opposite directions, you can have the motors running at half speed, but still producing the same pressure out of the compressor. And this, having a motor that can run at lower speed, is a key element and key enabler to be able to complete this project. This compressor is also a wet gas compressor that can compress multi-phase gas. And multi-phase, that's just the fact that it's both gas and liquids and sand mixed together. And we can see an illustration of that here, which is quite cool, where you have the compressor here compressing this mixture. So with these 2 main problems solved, there's also another problem that had been solved in the past, but OneSubsea had a solution for. And that is the very long power cable that's needed, 120 kilometers long. So here we have to review a bit of basic electric fundamentals. These motors on the seabed requires 32 megawatts of power. That's a lot. And we know that power is the product of voltage times current. So if you want to have 32 megawatts of power, you need to have a very high voltage or very high current. The The problem with current is that the higher current you have, the more losses you will have in the cable, or you need to have a huge cable. And we can actually see that the loss in the cable will increase proportionally by the square of the current. So obviously a higher voltage is beneficial for the losses. However, the motor needs to have its correct voltage, not just any voltage. So going from the basic topologies that we used to use, these two circles here, they symbolize a transformer. So usually we have a transformer that steps down the voltage from the main electrical grid to the correct voltage for the motor controller. The motor controller then outputs the correct voltage and the correct frequency for the motor, and the motor is happy. This works with short cables. With slightly longer cables and bigger motors, we also need to have a transformer on the output of the motor controller to increase the voltage to the correct level. However, in projects like Ohm and Lange, the power cable is so long that we need to increase the power level to a much higher voltage. In Ohm and Lange, it's more than 40 kilovolts on the power cable between the motor controller and the motor. But we need to have a transformer after the motor controller, and we need to have a subsea transformer before it goes into the motor again. Putting a subsea transformer into a project increases the complexity. And always when you deal with putting components on the seabed, you need to consider what happens if something goes wrong. And in electrical projects, one of the main considerations is what happens if we have an earth fault. And this is where I could go deep into the technicalities of what an earth fault is, but let's just say it's a leakage from a power cable. So we have current leaking out a place where it shouldn't leak. It could be a wire that is connected to the motor instead of the motor connection. It could be an exposed wire to the seabed, and then you have current flowing out in the sea. And there was an internal discussion in one subsea discussing whether or not they could keep running the motors if there was an earth fault. And this ended up being a bachelor thesis for us, Einar B. and Jon Wilhelm Ulvås and I. We wrote a bachelor thesis this spring where we investigated whether or not an earth fault would affect the operation of the subsea motor. And we looked into different system designs. We looked at the different motor speeds and cable length. And we came up with a mathematical model. We did simulations, and then we did a laboratory experiment afterwards to confirm our results. So for the electrical model, that was one of the main challenges we had, because creating an electrical model, we need to simplify the system. However, when you simplify, it's very easy to oversimplify it, and suddenly you have a system that's not representative in earth fault scenario. But we managed to make a model that we could then transform into a mathematical model, and we could calculate the voltages and currents all along the system with earth fault. We then did simulations in MATLAB with Simulink, which is a toolbox to MATLAB where you can put in cables and motors and everything. And we could get out graphs of how the system would act per simulation. And at the end, we were able to do a laboratory experiment where we had a generator that you see up there on the right top connected to a transformer. And then we obviously didn't have a 120 kilometer long cable available. So we built the cable by using components like inductors and capacitors that would basically give the properties of the cable. And we could run the motor that you see in the lower right corner. And we could connect this to instruments and see how the system acts whenever we put in earth faults. So all the measurements and the calculations, all these three approaches basically came together and gave us the conclusion that in certain system designs, it was possible to keep running the motor with an earth fault. But even in these systems, if you wanted to keep running the motor, the voltages on certain parts of the system would increase by the square root of 3. So the isolations in the motor and the cable would have to be engineered to handle that. And that's obviously something you have to do before you put it on the seabed. Additionally, there was a fault current that was affected by the cable length and the motor speed. So the longer cable you have, the more fault current you will have. And that sounds a bit strange, but the reason for that is that if you have a fault at the end of the cable, so a leak at the end of the cable, leak of current going into the sea or to the ground, the only way for that current to return back in to the electrical system is through the cable. So the longer cable you have, the more current can flow back into the system. When it comes to the motor speed is directly affected by the frequency of the system. And the higher frequency also makes it easier for the current to go back into the system through the isolation of the cable. So if basically the conclusion was, if you want to keep running the motor with an earth fault, you need to put this in as a part of the engineering process to have extra isolations and extra big cables, basically, to keep it running until you can get it fixed. Yeah, and that's what I wanted to talk about today.
Thank you, Geir. That was very interesting. How big are these cables? I mean, we're used to in survey kind of positioning cables. And
yeah, they're like this.
They're pretty chunky.
Yeah, it's quite big.
What depth is that? Because we worked at when we were doing the surveys, and Jon Arvid here as well was key. We were very heavily involved in the original development of Ormen, and that was down to 800 meters. And the cold as well, does that have any effect on anything here, or is that actually irrelevant?
So the depth, like, it's starting out quite shallow, and then there's a very steep dive down to the actual gas field. And we calculate with between 900 and 1100 meters. The temperature is a part of the calculations, but in the electrical field, I mean, it's cooling, so that's a good thing. You saw in that illustration of the motor that there's a lot of pipes around the motor, and that's all cooling. So yeah.
So with an earth fault, I mean, you obviously hope that you don't get one, but if you do, that's not something can be easily replaced, is it? That's a rather technical undertaking to replace.
It is. I mean, that was a bit fun when we did this task. We asked the professors and everything at HVL questions about earth fault, and they basically just turned their back on us because that's everybody's nightmare. It's very difficult to troubleshoot. So it's not just replacing the part; it's also finding out where the actual fault is.
Okay, very interesting. Does anybody have any questions at all? Because you can't do anything, can't put any cables in without calling up the survey department. So, does anybody have any questions at all for Geir? Appreciate that's not strictly a survey theme, but at the same time, it's all interrelated. We can't do our thing without yours, and you can't do yours without us. So exactly, it's a very interesting topic. So, if there are no questions, I think we'll say thank you very much again to Geir. Thank you, Geir.
Thank you.
Okay, can I put that? Oh, there you go. Right. Okay. I think we're going to have a quick break. 15, 20 minutes. Talk to each other. Someone come up and say that they want to be a member of and help us on the NOSP board. And yeah, I think we'll meet back here in about 8:05, and we'll crack on with the other interesting presentations for this evening. Thank you very much. Can I just ask you to make sure you eat the food? I can't take all that home. I will try, but please eat the food, okay? I want to see all that food gone. You can leave some of the blue cheese though. I quite like blue cheese. I'd like to welcome to the stage Tonya. I only got to know you about a week ago or 2 weeks ago, stepped in at the very last minute. And when Tonya came up with this subject, I thought it was just bang on, because we've got geologists in the room, we've got surveyors, and in my department in DOF Subsea, we have geologists, we have surveyors, we have data processors. So I thought this brought another element to the evening's proceedings. So, and of course it's offshore wind, and everyone wants to talk about offshore wind, don't they? So no one wants to talk about oil and gas. So on that note, I will pass the floor over to you, Tonya.
Thank you. So yeah, I hope you're ready for something very different. And I hope I'm not talking about too much just geology. I hope I'm taking it to a level where you guys can enjoy it, and I'm just not babbling on about things I find interesting, because I find this super fun, but I understand if you guys don't. I'm a master's student at the University of Bergen. I'm currently in my last year of my master's, but I'm just starting on it, so this will be more of an introduction to my thesis and a little bit about what I've already done, but it's nowhere near finished, and so please don't ask any hard questions. I don't know the answers to them yet. I will in about a year, so get back to me. So I've called this the shallow geology of the Sørlige Nordsjø 2 offshore wind site. This is like a starter header, and then my actual thesis will have a much cooler, longer name, obviously. So I'm part of the Force Wind project, which is, it's offshore wind, of course. And it's kind of about advancing the geological understanding to optimize site selection for offshore wind. And we originally wanted to say that we are advancing surveying, but in a room full of so many people that know a lot about surveys, we decided against it. And our main partners are Equinor, GeoProvider, and the Research Council of Norway. So to start, I want to talk about the intention of the project. This is a figure from DNV's newest report for the Energy Transition Outlook. So the green line is today in 2023, and then we have up until the very important 2050 goal year. I want you guys to look at these blue colors over here, especially the fixed offshore wind coloring. You can see towards the 2050, we expect this part of the offshore wind to really increase. And to do this, we have to actually have the money to do it, and we have to have people that know a lot about the shallow geology of the North Sea to actually get this done. This bottom fixed offshore wind, they are very inspired by the oil and gas industry in the way that they are placed on the seabed, or in the seabed rather. And you can imagine placing all of these oil and gas structures on a very large area, and you can never know everything about like a 2,000 square kilometers area. So we want to know as much as possible using as little as possible. So my goal and this project's goal is kind of to try to reduce costs for the future sites with similar geology to what I'm working on, so we don't have to do all of the work again and again. And try to not use the very conservative approaches. The more we know, the cheaper fundamentals we can use while it's still being safe and effective. A little bit about my project. This is a little illustration I made. It's not to scale. Birds are not that big. Just have to get that out there. I just thought they were pretty. So, the stuff that's important for the fundamentals for offshore wind is the first 60 to 100 meters. So I will try to illustrate this with kind of this jacket type foundation. kind of how deep it goes in comparison to the geology I'm going to be looking at. I'm going to look at the first 500 milliseconds in seismic data. I'm going to show that later for those of you that have no clue what I'm talking about. And yeah, the Sørlige Nordsjø 2, from now on called SN2, is a particularly heterogeneous area because of recent glaciations. And for this, we're going to try to integrate geological data with geotechnical data. I'm not doing the main of it. I'm not actually looking at the cores fresh, but I'm going to use the information from them. And yeah, my main thing is these channel and valley-like features that has been created under these ice sheets, which is kind of a pain when it comes to geology and knowing what's down there, because they're just everywhere. And as I will show you, they have very different geotechnical properties that we have to know of before we hammer something into it. A little bit about the geological background. I've tried to use this image to show that this is the SN2 site and this is the latest ice age, so the Vercillian maximum. It's very close to the site, so we can imagine that the glaciation went kind of back and forth over this area a couple of times, just making it even worse. This also shows some of the tunnel valleys that has been found from other papers, largely over here. Do you have to turn it down? I wear heels for this. Yeah, anyway. A tunnel valley, it is a pressurized subglacial meltwater valley, and they are very large. They're like up to 400 meters depth, and they, yeah, some of the tunnel valleys even in size the Pleistocene unconformity. So that would be like down below here. This is a seismic line. I will show you guys where this is from later, where I've kind of outlined what one of these might look like. So they're just big U-shaped, for me, very obvious to see. But yeah, a little bit about how they are formed, because it's a little bit important, at least for the geotechnical properties. First, we have meltwater eroding subglacially. After that, we have adverse slope cliniforms depositing during the retreat. So this is just a lot of glacier deposits, very mixed, not very sandy, not very muddy, kind of a mix, and it's coarser at the top. The next is a more pro-glacial basin deposit with glacial-lacustrine/marine, so more muddy. And lastly, we have the infill of like a deltaic cliniforms, which again has a whole nother set of properties. And the thing is, none of these are better or worse for the offshore wind farms, but we have to know about them in beforehand, because if you just place something on top of a clay, it might not deal with the weight the same way as we expect the sand and so on. So the database, I'm using 4 3D seismic volumes, no more no less, which covers 90% of my area. 2 of them are quite good. Those are the like MC3D 2008 and 2013. I will show you guys a lot from the 2008 one, which is up there. So yeah, this one, this is where I've shown this cross line from. And I want to show this because down here is salt, and I don't care about anything below here really. That's what I guess everyone else cares about. But I'm going to look at these like top 500 millisecond depths. And for the people that are looking at strictly just the offshore wind part, it's like this very little area which is basically ruined by an horrible seabed reflector. This is because these are processed to look at much deeper geology in relation to the exploration surveys. So that's kind of a bummer for me. But they also have strong acquisition line imprints, and I'm working on getting an updated version of the 2008 one, which has less of these imprints, which really helps me. But yeah, I also have some 2D seismic lines. Those are those white ones here. I haven't looked at them as much. I prefer the 3D seismic. But I also have regional 2D seismic that I'm going to try to make some regional surfaces and connect it with the Norwegian channel and kind of an outspill from the Norwegian channel. The next database I have is 900 kilometers of topaz data. So topaz is very, very shallow type of seismic. It's acquired using sub-bottom profiler system, and it has a very high vertical resolution of 0.3 meters, which is high luxury from looking at seismic. If I go back, this was like 10-meter resolution in the shallow section, and here is 0.3 meters. So you can see a lot. This is an example from the topaz data. For me as a geologist, I see a lot of cool stuff here. You might just see lines, and that's totally fine. I also have 13 fiber cores, which are scattered around the area, which I might look at, might not. It's not my focus, but they are have a high value in this project in the force wind. So I've done a lot of playing around with my seismic. I mainly use Petrel. I'm going to learn geoteric because I find that my RGB colors are ugly. They won't turn white. But yeah, I've done mainly stuff on my 2008 survey, so variance and RMS. These are attributes that I extract from the volume. They show me a lot of cool stuff. Just this RMS one, I would say that the light colors are more sandy and the dark colors are more muddy. And then for the variance, it's kind of shows the edges of stuff. So we can really see some of these tunnel valleys actually just branching along the area. So it's very nice. And then I've illustrated some of my observations on some lines that I will show. I also have done something I really love to do, which is called an opacity rendering. And that's where you extract a box probe from a volume and remove or make all the low amplitudes transparent, and then you can look at the volume in 3D and look at all the high amplitudes as structures. So it's really useful for me to see where I want to focus on. So especially this area in the middle, I can kind of see it in 3D. I can kind of say, okay, I think this goes on top of the other, and then I can look at the cross-section and be like, okay, that's how it looks in cross-section. I can look for that other places. And it looks pretty cool, I think. So that's a plus. This is a very nice RGB blend time slice at minus 140 milliseconds. For me, I see a lot of great structures. We have something that might look like a meandering river. It's smaller and has all these bends. And then we have something that might look like a tunnel valley, this darker kind of shadow. And then up here, we have something that very much looks like a fan. So it might be a fluvial fan or an ice front fan or a washout fan. And then we have these round, lower frequency dots down here that might be subglacial lakes or just lakes. This is an example of how this area in variance with like the valleys overlapping each other, how they look in seismic. So I've tried to draw on what I think looked like at least 3 of these generations of tunnel valleys. So I characterize these by looking at which of them cuts into the other. So first we have this green one, which is cut into by this orange one, and then again by the third lighter yellow one. So this is kind of what I will try to do for either all of the tunnel valleys in the area or most of them. This is the topaz, which is much, much more shallow. As you can see, these go down to around 85 milliseconds in comparison to the last one that went down to around like 400 or 500. So we're like up in this seabed reflector now. Here it's very obvious to me to see some lateral accretion in this channel, and then there's a larger channel kind of draping over. So again, these are kind of 2 generations. There's an older one and there's a younger one. And I feel like I might be able to see them on my RGB blend time slice. There's a thin kind of strong channel going here, which might be this one. And then there's a wider channel going below it, which it's not that visible when I blow it up this big, but it might be this wider channel. So that would be kind of cool for me if I can do this for more of these channel and valley-like features. Lastly, next steps. I still have a lot of work to do. I have to apply my workflow to the other 3D seismic volumes. So doing the variance, RMS, RGB blend, opacity rendering, a lot of hours in Petrel. Then I want to look at the regional 2D lines and look for context, so create regional surfaces. Then I want to interpret the base of the oldest of these big valleys and maybe make something like this where you can see them in 3D, which really helps create an understanding of them. And then I have to choose the direction of my thesis. So I have 2 that I really like. The first one is to create a catalog with all of the structures that are present in the SN2 area. So channels, tunnel valleys, lakes, all of that good stuff. Look at the seismic phases, shape, size, potential geohazards for each of them. Not go into depth for each of them, but yeah, make a catalog that other people can use. Then divide them into generations and correlate them with glacial and interglacial periods, and then try to connect them with research from the surrounding areas. We have a lot of research from the Danish section, actually, and quite a bit from the UK side as well. I think Norway is we're not first when it comes to tunnel valleys. And then B is to choose one smaller area, so maybe this one, which is very, very interesting. It has a lot of overlapping channel-like feature, valley-like features, and I can try to do a more in-depth analysis on this. So create a 3D model for these overlapping valleys and a very detailed description of infill and maybe geotechnical properties, and then do a smaller scale correlation for the glaciation, and maybe look at shallow gas, which is super popular. I know that looking at new fields like Pion, which is shallow gas in this quaternary package, they also need people to look at these types of data. Or a lot of these valleys are very suspiciously bright in seismic, which might indicate shallow gas. And we also have to know where that is, because that's a huge potential geohazards for these offshore windmills. To summarize, so I hope to help reduce the cost for these future installations of offshore wind farms with similar geology, because I think the SN2 sites, it's applicable to a lot of the North Sea plateau. The whole area has a lot of these valleys features. I want to interpret the shallow geology of the SN2 sites, focusing on these tunnel valleys, I have a database of 4 3D seismic cores, a lot of 2D seismic, topaz data, and vibra cores. Yeah, my results include attribute volumes, RGB blended volumes, passage renderings, interpreted lines, and my next steps is to apply this to all of my data and hopefully choose a direction. And if some of you guys have opinions of which of these directions might actually be the most useful to the industry, please tell me, because I have a hard time choosing. But yeah, that's what I got.
Thank you, Tonya. That was very interesting. I can tell how enthusiastic you are about the subject. That really came out during your presentation. You got a couple of companies mentioned here. Is this open source data that you have, or has it been provided by the likes of Equinor, or how did you get your hands on such data?
So most of it is open sourced, but I got a data set that I'm not allowed to show you with super interesting data. But most of this, I have a PhD actually called Hannah Petri in Equinor, which has done a lot of the same things as me. So I've gotten most of it from her. Yeah.
So how much, I mean, a lot of us in the industry here will know about seismic data, and there exists a lot of seismic data already.
Yeah.
Can that be used? Is that predominantly what's going to be tried to be used to interpret the data, or do you see the need for us as surveyors, for example, to go out and gather more data of a more refined quality? Because you're only talking about the top surface, aren't you? First 30 meters, anything else is uninteresting. And I probably shouldn't say that to you, but to me, is that fair to say that we may have to go out and collect more data, or do you think the data exists?
So I think we need to have a mixture of both. It would be lovely to have very high resolution shallow data. I worked with some from the Nordkapp Basin, which was so much fun to work with. But I think we have to develop the skills to kind of draw out as much as possible from what we already have, as well to lower the cost. I think it's a good idea to get well versed with these kind of more complex attribute analysis. And yeah, as you saw, from the level where the seabed reflector just kind of ruins everything, when I do the RGB blend, I can actually look at a lot of different structures. So.
And I know Equinor are just one of many players in the business, but have you spoken to companies about what they're looking for? Is that what you were pitching towards with your conclusion, that you need some direction about, because there are lots of companies popping up all over the place now that want to put in wind farms. So have you had dialogue with them yet at all, or you're trying?
I try to ask people when I meet them, but I haven't met the right people yet. It's kind of a niche area, but actually one part of the SN2 is being bid on as we speak, and will be granted in like the new year. So that's pretty exciting. But yeah, I don't know. That's kind of what I want to figure out, what can be the most useful. So it's actually not just for the thesis. Although that's fine.
I might be able to help you out there. So I think we certainly, with the company I represent anyway, we do a lot of this at the moment, and you can see that there's a need for a greater understanding. So maybe we can have a chat after.
Yeah,
does anyone have any questions at all? It's very dark here. I can't really see anyone. But
I can't see anyone.
But this is such a there you go. This is such a fundamental part of what we do. In the survey field, it's not just positioning on surface. It's below the surface, and it's what's below the seabed as well, at least in the first 5 to 30 meters. So no more questions at all? Yeah, go for it. Yeah.
Oh no.
Yeah, you want to be worried. You really want to be worried.
No. As a surveyor, which we frequently call out to in areas where people are going to put a monopile down, or especially a jack-up rig. Yeah. will go around and they spend a lot of money moving rocks out of the blade so the jacket blade doesn't get damaged or yeah. And one thing that's always puzzled me, I've never understood this, right? We pick all this stuff up. Quite recently, I was on a job where we just saw this tiny bit sticking out. You know, it was just tiny. Grab it, massive boulder, way beyond. It should have been there. We put it out, move it out of the way. I think, oh, great, magic, all done. But with my limited knowledge of geology, I'm assuming that sediment type there, all the way down to 30 or 60 meters or however far that pile or whatever it is going, there's going to be a lot more of those rocks. We just saw the ones on the surface, and they only removed them. You know, why are those rocks
there?
Well, not why they're there, I can understand that, but why are they not important? Why, if the one on the surface isn't?
But you're talking strictly oil and gas, though, aren't you? Your experience.
No, I'm talking strictly. No.
Well, that would be foolhardy to only take the ones on the surface. But I think that's the problem that we've got at the moment with the industry. It's in its infancy. And I think there's a lot of companies that think that, oh, well, it's just, or for a good example is working in shallow water. Oh, working in shallow water, how difficult can it be? That's actually more difficult than working in deeper water. So I think it's that sort of mentality that you can see the stuff on the surface, but you just don't. I think
my point would be the study showing how many, so the rocks that would be in the top, say 30 or 60 or however many meters are going to pile would be of interest.
Yeah, we actually have a kind of a politician answer for you. We have to kind of avoid it, maybe, try to avoid them. So, because we're like, yeah, you can't go and remove them.
No.
That's too much. But actually, for the topaz data, you can see them. It's so detailed that you can see them. So, a lot of work with the Utsira Nord section where they're using suction anchors. That's a very big no-no for big boulders, of obvious reason. If you they break the suction. They have done a lot of work mapping these boulders to try to avoid them, especially the very big ones. I'm not that sure about the smaller ones, but I feel like, that we need just to be very detailed so we don't have to move these big mountains and deeper down, I guess.
well, it's simply not going to be cost effective in the wind
No.
industry. It's not like oil and
can't.
gas where the money comes trickling in.
No.
The wind is a lot. It's a lot. You've got to be more frugal.
Yes.
But it's
Very-
easier as well because then you can just move the suction anchor to a location where there aren't any rocks. Sure.
Yeah, we don't need to hit anything.
Yeah.
Yeah.
But then you need very detailed
Yeah.
surveys over a large area.
Yes. That's gonna.
To give you the options to choose a location that's not screwed.
Yeah.
Can I ask a quick question? And I might embarrass myself in front of some peers here, but the milliseconds, is that the depth? Because I was going to
Oh,
work,
sorry.
because that wasn't quite clear how.
It's in two-way time, so it's how long it takes for the wave to go down and up again.
Okay, so 700 milliseconds is 350 meters.
No.
The other way.
No.
See, I told you.
I'm sorry. It's I wish it was that. It's this is.
Okay, don't worry about it.
Yeah.
See, I told you. I'm just going to go home now. Okay, any more questions at all? I think we'll crack on with the last one, which...
Got one, but just one quick question. When you go to do the image processing for your next seismic volumes after you've already done the first one, do you think it's going to be about the same? Like, if you had written a Python script to do the first one, would you be able to roughly run the same script on all four? Or is it
No.
art forms? Okay.
Yeah, I have to. Firstly, I do it by hand because Petrel they can do a lot. It doesn't take that much time to actually do all the processes. You kind of just have to know what you want to do. And for each of the volumes, you kind of have to choose different parameters. Some of them are very bad quality and I have to choose something else. And even for the RGB blend, which is about frequencies, I have to change the color scale while I scroll down into the deeper sections because it's totally different. So it's very much of like a creative process, making it look good with colors and yeah, if that answers your question, yeah.
Cool. Thank you very much, Tonya. Very, very nice.
Thanks.
Thank you. Okay. Okay, we've got one more, and then I think what I'm looking forward to a little bit towards the end of this presentation is a bit of a discussion about how, and there's plenty of people from the industry here, Julian amongst one, Jan Arvid, and then we'll have, just get a little bit of an interaction going and see if there's anything that we can do. And somebody please take some notes, because otherwise I'm going to forget. So I think we'll bring to the table here, Högskolan på Västlanda. I can't remember all your guys. Do you want to come up here? I can't remember any of you, sorry. So, yeah.
I think we're going to use this one and just...
because we're kind of...
Yeah. How long do you reckon? 5 or 10 minutes or a bit longer?
10, 15 maybe?
That'd be nice. I think we could do about 10 minutes.
Ja, vi bara delar på den. Vi må bare gjerne ha det litt fint.
Is it on? Yeah, nice. Okay, so we're from HVL, and we're here we have been invited to present the course of our studies for you in order to kind of get more attention around the surveying at HVL and hopefully get more of the students interested in the offshore industry as a possible way to work. We are third-year students, all of us, in a bachelor program. So we're all in our last year, and we'll just start with introducing ourselves.
Yes, good evening everyone. My name is Jonander Davlios Albert.
My name is Rico.
And I'm Amun. Yeah, that's basically what we have to say about ourselves. There's not much more to say. We're students still, so we haven't really even started our bachelors. But in loose terms, what we're here to present is the bachelor program at HVL, or in English, the Western Norway University of Applied Sciences. Quite a difficult word. I put it there just to remember it. It's a bachelor in surveying with quite a heavy focus at cadastral surveying, at least in the start of the study. But we get into the good parts in the third or fourth semester during the second year of the bachelor. So we'll go quite quickly through the first year of the studies. All the courses are obligatory, and we don't really have any choices here. We're kind of cuddled, and they have been kind of kind to us with the way they introduce the basic courses. We get an introduction to GIS systems and the rules of mapping, the geometry rules, and basically some quite basic mathematics that we need further on, just so that everybody is up to date with the mathematics that we need. And we get an introduction to the cadastral surveying systems, which is, as I mentioned, quite the focus until the third semester of the course. In the second semester, we also have we start with the more important stuff for surveying, with statistics and how they correlate with surveying, as well as some more cadastral systems courses, which aren't really that interesting for you guys. But the juicy stuff starts in the second year.
Yeah, so in the third semester, we have a geographic information system analysis, where we use just some general GIS techniques to solve different cases, basically. So we are using spatial and racial data to solve various of cases, where we analyze it and use it in a better way and visualize it for the common man. And we also had a field trip to Røst, which is a small island in Lofoten, very beautiful, where we did more field work, where we got to use GNSS equipment and total stations, so we got more in touch with that. And we also got to use this analyze knowledge to process and analyze the data we got. That is really useful, both on and offshore. In the fourth semester, we had a subject called engineering surveying, where we got this data from basic geodesy, where we plan and perform surveying, so we could emphasize the usability of the data. So we found errors that we could try to solve, and also do the measurements more precise for other use. And we also have a opportunity to choose another subject called practical summer internship, or studiepraxis, that gives us the opportunity to work out in different industries with real work. So yeah, that is really useful both for us students, but also the industry, to get to know the student better and to get more experience.
So on to the third and final year and the fifth semester, which we are going through right now. We have our main subject called Geographic Information Science, which is a really difficult subject, in my opinion. It's also one of the most important subjects that we're going through. It focuses on methods and techniques for processing and visualization of geographical data. And we use this to analyze and operate. A big part of this subject is also the cartographic projections, where we gain knowledge in applied spatial data. And we also, of course, use this to provide coordinate systems and to visualize this data for people that, of course, don't understand it. And on to the spring of 2024, we are starting to write our bachelor thesis. And of course, to do this, we need some cases or problem stands. So to you guys that are here representing the industry, if you have something for us, we would really like to sit down and discuss it with you. And if you have some problems, maybe we could help you solve them. But this semester doesn't only contain the bachelor. We also have something called industrial surveying and laser scanning, which is probably the most offshore and marine survey focused subject that we have. This subject focuses on prefabrication and construction, which contains the construction of 3D objects. In land survey, this would be, of course, through photos and laser scanning through, for instance, drones to recreate, for example, buildings. And in the offshore bit, it would be the same for ROVs, sonars, which we also will get an introduction to through this course. And that will also give us knowledge about reconstructing or just constructing piping and steel structures, both on and offshores. So yeah, to finish it off, why is our study relevant to you? As you've seen from our introduction, the difference between land and marine survey aren't that big. Many of the things we do share many similarities to the offshore and to the marine survey. For instance, we use GNSS for positioning and navigation in the same way that you use GPS. And we also use get an introduction to sonars and gyroscopes to keep orientation. And we also learn to analyze and, of course, as I mentioned, visualize the data through different programs such as AutoCAD, QGIS, and ArcGIS, which also teaches us to use and implement the data, which we can read offshore as well.
Yeah, we'll just skip this and go straight to wanting to invite you guys to kind of brainstorm or discuss with us how we as students or in academia can come more in contact with the industry that you represent, because even though we get to some relevant information, we're not really in contact with the offshore industry within surveying, and it's hard for us to know how we can apply our knowledge or the knowledge we gather through our studies to the offshore industry. And we would really love some ideas to how the industry and academia could work better together to let us students at the HVL know more about the possibilities in the offshore industry.
All right. Thank you. Nice one, gents. So I get the impression that everything about your course is geared towards land. Is that fair to say? You mentioned offshore. Yeah. So even though Stig, your leader, he has worked with Fugro at Loxawalk, he hasn't taken the initiative to maybe introduce a hydrographic survey discipline, or I know we've got geology at another university, but is that something, would a syllabus like a I don't actually know how it all is broken down, but would a hydrographic survey module be advantageous to introduce to you? Is that something? Okay, but
so the subject that we can take in the spring of 24, the laser scanning subject, a small bit of that subject is hydrographic survey, and we would of course like to make this a much bigger part of our studies. Yeah, because as you've seen, the collection of data between land and marine is quite similar. The basics are the same.
So can I then ask, is had you not known about NOSP or this event, like this time last year, there wouldn't have been a student in the room. I guarantee that. Is that's helped bring a profile of what actually happens offshore into your lives?
Definitely.
Yeah. Okay. So maybe then NOSP needs to be some sort of conduit between the two, because then we can gather the information that was required by industry, and we can maybe put industry in touch with academia and vice versa. Is that's yes?
That would definitely be advantageous.
Because you, if I'm correct, Verseth and both at DOF Subsea as well actually have had experience with Högskolan för Västlandet before, maybe before your time. But do you know anything about that, or why that died out? Because that was an introduction. Do you know anything about that at all?
I know that Verseth has been a guest presenter in the laser scanning or laser scanning course. Yeah. But I'm not sure why it's that kind of died down, or if it died down.
I definitely know that they did something, because I know they're based in Bergen and they have access to some nice USVs. But is there anybody, I'm going to point a finger at you, Håvard, because I know that you worked at my company this summer and I think you had a good time. Is there anything that you mentioned to me even before this event, that vessel visits and getting involved in projects, be that at a very, very low level, it just helps. Is there anything you wanted to contribute here? Yep. Which you've obviously read cover to cover. Yeah. I did actually, there is a company called Skill Trade. I don't know if you're familiar with them. Yeah, you are. Okay. Because I brought the books along. Please don't take them away. They're mine. But there's some takeaway documents as well. I've got 10 printed out. So that's a course that is actually conducted down in the Netherlands. And Johan Stam has been doing that for years. And I haven't used that course, but I know that some people do, and lots of students come from around the world, but it costs a lot of money and you need to get some sort of sponsorship. But again, I think maybe NOSP needs to up their interest a bit here and be that kind of knutepunkt between industry and academia. Yeah. Okay. Is there any, like, yeah, go ahead.
Thank you. Oh, yeah, sure.
The most of these courses are now online.
Yeah.
You can do it online. Yeah.
Yeah. Yes. Go ahead.
But that's different,
Yeah.
of course, in the lecture room. Yeah.
But it's much better to be on a boat.
What about the masters in Plymouth?
It's gone.
It's gone now.
I think
You're kidding me.
Yeah, they're planning to move all up to Bristol.
Why Bristol?
Yeah.
Bristol's no fun. Did you want to say something?
There's a lot of them get.
No, because
I mean, if there is time.
there's huh?
Because that 1 year masters
Hang on.
in hydrographic was the perfect. You do this to get your basic and get your maths, and then they did all your acoustic nav and all the stuff that you don't do in Norway, and that was a very popular, successful.
Yeah, but there's the same with new. Is this on? Hello. Oh yeah, it's the same with the geospatial course in Newcastle, which is used to be another great springboard for surveyors from university. That's finishing in 2 years' time. That won't be anymore. Geomatics in Newcastle, and that's got a hell of a history. Sorry, this is kind of we're just talking about the UK now, but I think the whole point is that we've got to try to get something over here, because you've got a maritime history, you've got a phenomenal coastline, you've got an oil and gas industry. I can't understand how you haven't had this up until now. It's probably why there are so many goddamn Brits over here. And I think the big takeaway, I think, is that we need to step up our game to be a conduit, as I mentioned, for you guys. But I think we need help from industry, maybe like the likes of OneSubsea and Fugro, to know what we're gonna need from you lot in the years to come, because it's changing at a phenomenal rate at the moment. New technology and obviously an introduction to geology may not sound correct, but it does help when you get offshore. I don't have that background, and we have to bring in geologists, and I know there are some geologists here, so it's to try to find that ground. So is there anyone got any, you girls, Natalia and Natasha, was that correct? Sorry, got it wrong. But you two were with my company as well this year. You enjoyed yourselves a lot. Was there any kind of feedback you would give about what to do to try to make it more encouraging, or you wouldn't have heard about us otherwise, this Geoproxys dog, and what companies or NOSP or, okay, both, yeah? All right. Okay, go ahead. Yeah, but then why don't? Yeah, but then they need to reach out to us. I mean, the problem is it's actually very demanding, all this work, and we've all got our day jobs, and some of us have got families, so that's the most demanding thing. So I think your lecturers need to get to do something as well, which was a bit disappointing. We didn't get any down here tonight, but maybe we can start that ball rolling. I did with Stig 2 years ago, but then it kind of, children, what a pain. But has anyone else got any kind of, Atla, I know this is kind of your pet subject, isn't it, with BSR here in Bergen as well? So you've got good experience of bringing in, what do you have?
The best idea, I think, is that university in Bergen, that this could be a part of it. They study the offshore, the hydrographic.
I think that's the best thing we can do.
You have to go and speak to the management and try to integrate it.
Yeah, and then get industry buy-in, and but it's something like studiepoeng, isn't it? If you can have some subject that
This is a typical land surveyor. Jens is working all his life offshore as a land surveyor.
from Högskolan på Västlandet, from HVL, eller or is
From Bergen.
yeah.
So there's never been an education for surveyors in Norway.
No, but now it's time to change that, isn't it? I think that has to be the goal ultimately. So I think, maybe we don't need to discuss this until the cows come home. Yeah, go ahead, Dalman.
Just like for the industry to be more visible for our students, some things that you could do is reach out to the student organizations or Linjeforening. We would be really happy to introduce you to the students. I am part of the styre i Linjeforeningen. And we would be really happy to have some more offshore interest in our students.
Remember Mike Robinson and Alan Bolton, for example.
Two Brits.
To name two,
Yeah.
But I mean, didn't they hit Plymouth when it was still running? It was a kind of a recruitment drive, as it were.
Yeah.
They did guest lectures or presentations.
I think we've all done it. I've done that as well, but I haven't done it here. That's the thing, and I think that.
I mean, that would be an obvious way.
Yeah. But how we're talking very last minute. So you're in your third year now. It's kind of a bit almost late. How is it actually beneficial to be earlier in, and how? Because I'm not talking like primary school or videregående, but maybe there's that we have to get in a little bit earlier to increase the kind of the presence or the opportunities that exist if you do. Is that fair to say? Rather than the third year, maybe we need to be first year or before that even.
In the start of the second year, I think that's the first time that we can choose some optional subjects.
Yeah.
So maybe some kind of hydrographic survey could be an optional survey where we get 10 studiepoeng. From an optional survey, an optional study.
Yeah.
So.
Okay. Gosh, we've got a lot of work to do.
What are you guys planning for your masters?
Oh.
We're not taking masters.
Yeah, okay.
We're on the bachelor's degrees, but of course, being here, being at the NOSP, we are interested in the marine survey part of it. So.
Sorry, is there a master's program for your line?
Not for marine, but for we have
Cadastral survey.
Okay, yeah, so
cadastral
there's
survey.
that's an option.
You don't really need a master's.
I wouldn't say so.
No, if you, no.
No.
Sorry, I didn't mean that you had to have one. I was just curious
Yeah,
as
of
to
course.
if that would what your options were.
Let's face it. You come out of university, you think you know everything. Yeah, because you've done a really, like we did it. Well, I did it. Geomatics. Yeah, I did a whole year of offshore survey. You think you know it. The first time you get offshore, you think, what the fuck? No. You know what I mean? It's all to do with attitude. As long as you've got your geography, your maths,
Yeah.
and the right attitude, you'll make it to the bachelor's.
I think the attitude's the most important, actually. So that's speaking from someone who almost completely failed his degree, but still got the best job on the planet. So I think there's a lot to be taken away from this. I think what's also interesting is that it's changing. It's a very dynamic industry. So try to, especially at the moment with USVs, AUVs, and autonomy remote ops, it's just very bewildering to keep up to speed with it. So it needs that constant attention as well. So. But I don't know. Go on then.
Oh, thank you. It's been a while. I forgot it. No, I didn't forget. Okay. So I think now Elizabeth Swan is now officially a NOSP member, and she will be more in charge of taking care of you guys and speed you up to the industry. So that's maybe something worth talking to her after, if she's here, of course. And I see that you are just about to finish your bachelor. You come to a NOSP and they want to throw you more hydrography courses on top of you to get you into the market. So maybe that's not the best solution for at least you guys. But on the long term, yes, of course. But the good news are that we are NOSP, so we are for offshore survey, but not purely hydrographic survey. So we do have a lot of, and I'm not sure if you remember, but we have a lot of point clouds and dimension controls, and we have companies like Anko that are our sponsors, and Veset from here, from Bergen. So you have immediate entrance in the market with the knowledge that you're gonna get in half a year. My company, for example, is also based just in dimension control and 3D scanning. So I think one of the things that maybe we NOSP can help you, the persons that have this speciality, is to maybe grow the sector for the 3D laser scanning offshore, and maybe do some presentations about that, bring up some companies, and that you can meet them and see, for example, use cases for that. We can also grow the LinkedIn website to promote you guys in the market. And I'm not going to say more. I mean, Elizabeth most likely have more ideas, and you guys have more ideas. But what I'm trying to say is that hydrography is, of course, something should be here. But what you guys study is also very high valuable for the offshore survey industry. And it's there, and we use it, and it's a high volume of work at the moment. So
I think that's the key, isn't it? It's trying to find that balance, because they'll have a phenomenal foundation, but they won't know what is expected offshore. And as Julian said, when you get offshore, it's completely different to what you expected anyway. So maybe you just need to do that anyway.
So
I might add that we did sections and a lead line. You know, so things were a bit different.
I did a sunshot. But I was thinking about other things, because you mentioned, and I think, Tonya, you mentioned that you were looking for some direction in regards to your masters, and you guys are looking for some sort of thesis for. So I think maybe the website, maybe we can develop that to be so it's somewhere you could go and say, look, put your name on a board and say, look, I want to do a hydrographic, or I want to do some sort of, and then we can get industry to come in and maybe just try and connect the two. Right, I think it needs a little bit of work, Lizzie, but it's one way that NOSP. I foresee this is exactly why NOSP exists, really, for that, to join industry with academia. So I think we've got a lot of. We're going to have to sit down and have more meetings on Fridays, or longer meetings on Fridays. So. Okay, is there anything else anyone over that side wants to say? Because you've been very quiet. Atler again.
Yeah, just an update. From the Corona time, a lot of people, I'm 68. I should have retired. But a lot of guys from my age, when I like in the 90s, they was my age, they didn't read on the certificates going offshore during the Corona, and they just retired. So I wouldn't be surprised if more than 10% maybe of the surveyors has gone out to the market.
I had an interesting conversation where I think I was the last person, one offshore surveyor I spoke to. He literally, after he hung up the phone, he retired. So that happened during COVID. I completely that.
Now the industry can say it, and I can say it.
Yeah.
We are vacancy the whole world.
Yeah.
People, Indonesia, from Russians, they still, allowed to use the Russians, but.
Well, some companies, but it is true that there are phenomenal opportunities in this industry at the moment. I see it on a daily basis. We struggle to put bums on seats. I've got a vessel over in doing an AUV survey, and they're only doing an AUV survey half the day because they can't get crew for the other half. That's losing us money. And it's just a shame that the industry hasn't had the foresight to bring people in. So maybe tonight can be a step forward to maybe some different times, because it will only grow. There's a lot of the offshore has not been explored from a scientific point of view, but then there's obviously we're moving offshore with wind, etc. And wind, as you've shown, is just going to explode in the next couple of years. It might go a little bit down. I'm anticipating a little bit down once people go, the fun kind of when reality hits, but it will then pick up again. So yeah, there's lots to be enthusiastic about. So, okay, anyone? Let's go downstairs and drink beer. Yes. Thank you very much for your time.